Okay, so this is the first page of notes from yesterday, and there's nothing wrong with them, Mari. I'm not fixing a mistake. But I want to look at 13 and talk about Carol, because somebody was making some comments yesterday about Carol and how ridiculous this seems, so I wanted to actually work this problem. So it says Carol wants to be a millionaire if she saves 1 cent on the first day, 2 cents on the next day, 4 cents on the third day, and so on. How many days will it take her to save $1 million? And so I want you to just think about it. I don't want you touching your calculator and like actually trying to figure it out. I just want you to think about what you think might make sense and put a number over here that how many days you think it's going to take for her to get to $1 million. I mean, and I'm not going to, in the end, I might ask some people, but if you don't want to tell me your number, it's fine. I mean, I'm not going to say you have to tell me your number. And it's just, so it's really just between you and yourself. Just think of something, how many days you think it would take her. Write it down right here, like commit to it. It's okay if you're wrong. You don't have to share it with your neighbor or anything. Just come up with something, okay? So, 5, 4, 3, 2, 1. If you haven't written down a number, write down a number, and then we're going to work the problem. All right, so Carol wants to be a millionaire, because who doesn't, right? She saves 1 cent the first day, 2 cents the next day. So A1 is what? $0.01 is what? 0.01. 0.01. Okay? And then, is this arithmetic or geometric? Geometric. So what is R? 2, because each day it doubles, right? So R is 2. I don't know what N is. N is what I'm looking for, right? But I do know that the sum of all of that is I want it to be $1 million. Right. So then I can substitute all this in to our geometric series over there, and we'd have 1 million, make sure you use enough zeros, is equal to A1, which is 0.01, times 1 minus R, which is 2, to the n power, because we don't know what n is, right, over 1 minus 2. Everybody agree so far? Okay, so let's try and minimize all the stuff we have to rewrite. 1 minus 2 is -1. Do we all agree with that? So this -1 that's in the denominator, I'm going to go ahead and just multiply both sides by a -1 and make this a -$1 million equals 0.01 times 1 minus 2 to the n power. Everybody good with that? You understand what I did there? So what would my next step be? Divide by 0.01. So go ahead and do that. It's a lot of zeros, right? How many zeros? 8. So it's -$100 million, right? Or -$100 million. And then that's equal to 1 minus 2 to the n power. So what would my next step be? Subtract 1. So I'm going to get negative, and then I have 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then the 1 at the end. That's equal to -2 to the n power. Now, what do I have to do to get n out of the exponent? How do you do that? The log, right? You can take the log of both sides. Can you take the log of a negative number? No. So if I multiply by -1, then those just both become positive. I don't have to rewrite. I'll just make them positive. Your other option is to try and get this into something that has a base 2, right? 2 to the, 2 to the whatever power. I don't think that's going to work there, so I wouldn't try it, but that is another option. But I can take the log of both sides. So when I do that, and I wouldn't start pushing buttons in the calculator just yet. So I want to take the log. Oh, in the log, does it log base 10 or is it natural log, or does it matter? Log base 10. Could I take the natural log of both sides? You could take log base 72 of both sides if you want. It doesn't matter as long as they're the same, right? And so log base 10 is fine. Natural log is fine. In calculus, you're going to be doing natural log more than log at all. But on the calculator, it's just a button, so it really doesn't matter anyway at this point. So we'll just take the log, the regular log, because I know you're more comfortable with that. And that's equal to, what happens when I take the log over here? N comes out to the front. So n times the log of 2 And then to get n by itself, what would I do? Divide. And so I'm going to divide both sides by the log of 2, and now is when I would do it in the calculator, so I could just do it all at once. So you get that n is equal to 26.575. What does n represent? Days. So your answer then is going to be 27 days until she saves $1 million. Were anybody? There's no way. I mean, you have to have the money to be able to save it. Let's put it that way too. I get that, yeah. But was anybody close to that? Does anybody have like a really, really big number? Yeah. What was your number? 100,000. Okay. Mine's 1,000. Yeah. A month? Okay. And because this does seem ridiculous, right? It seems like there's no way that that's possible, but it is. That's what happens with exponentials. And somebody reminded me yesterday that y'all were the group that I read that book to, because I don't read it every year, but that rice, right? She wanted to get paid she wants a grain of rice. The next day she wanted 2 grains of rice, and the king thought it was ridiculous. That's just crazy. But then before long, she pretty much owned the kingdom or whatever it was. But so the whole concept of what can happen with numbers, it's hard to comprehend sometimes, but it's 27 days. So there you go. All right. So grab your notes for today. And this is going on 156. Okay, so we've done arithmetic and we've done geometric for sequences and series. And each time it was like, this is arithmetic sequences. This is arithmetic series. This is pretty much it all mixed up. We are definitely not doing every single one of these. We're not even, on this first page, we're not even actually completely working any of the problems. We're just going to talk about them because it's the same stuff you've been doing. It's not new material. The new part of this, I guess, is just that you have to be able to identify them. And sometimes it's really easy to look at it and identify it. And other times you have to kind of actually do something on your calculator, right? Do some arithmetic or whatever. So let's look at, let's just look at let's look at the directions first of all. It says determine whether the sequence is arithmetic, geometric, or neither. Then it says if arithmetic or geometric, write the equation and find A7. But we're not going to do that because you can do that, right? Do we all agree? Like you get what you've been doing? All right, so we're just going to kind of do the new part of it. It's not worth our time. So on number 1, do you think it could be arithmetic before you even start doing anything with your numbers? No, because the signs change, right? And if the signs change, it can't be arithmetic. So we want to see if it's geometric, right? If you take negative 42 and divide by 14, what do you get? You get 3? Negative 3. You get negative 3, right? That by itself means nothing, right? Unless you're told that it's geometric. Now you have to take 126 and divide it by a negative 42. What does that give you? Negative 3. So since you've got it twice, that's how you know for sure it's geometric. And if you can multiply them in your head, you don't have to actually do it on the calculator, but you got to make sure you're going to get the same thing, so that makes this geometric. Does that make sense? All right. So what do you think about number 2? Geometric? Okay, so let's try that. We're going to take negative 1 divided by 1. That's going to give me a negative 1. 2 divided by negative 1 is negative 2. Is it geometric? No, because you don't have a common ratio. Can't be arithmetic because the signs are opposite, plus arithmetic just doesn't make sense with the numbers that are there, right? So this one is neither. So be careful. That's why I'm saying you have to actually test them, whether it's with the calculator or in your head or whatever you're doing, right? So what is at first glance, what does 3 look like it is? Okay, arithmetic, right? So then you have to make sure that the numbers are the same. So if I take 44 minus 53, what do I get? Negative 9. And then 35 minus 44 is negative 9. So it's arithmetic. Okay. Make sense? Questions? All right, you do 4, 5, and 6. And all I want to know is arithmetic or geometric. You're not actually working the whole thing. And at first glance, you may not be able to tell if it's arithmetic or geometric yourself. So you might have to test it arithmetically, then test it geometrically. You know, you might have to actually do both, but you got the calculator, so we're good. Yes, 4, 5, and 6. Do it anyway, because I said so. Number 4. What do you think about number 4? Okay. Arithmetic. That's different than... Right, but they have different meanings. It's kind of like wind and wind. Because I said so. I'll hurt you. Okay, arithmetic. All right, what about number 5? It's neither. Good. And what about 6? Geometric. All right, so are we good on that? Yes, okay. And then once you figure that out, you can solve them, right? So if you look down, those are sequences. When you get to series, you're identifying them the exact same way. They just have addition signs, right? So you can clearly tell here, this one's pretty easy, that you're just adding 7 each time, so that makes it arithmetic. Make me say arithmetic. And then 10, what is 10? Yeah, we're multiplying by -5, so it's geometric. Like sometimes you can just look at them and it's really easy to identify, but make sure you're actually identifying them. Some of them you got to do some work on it. All right, flip it over and let's go down to 15. It's the same thing. We're not working and we're just going to identify. It says determine whether the series is arithmetic or geometric, and that's the only part we're going to do. So let's look at 15. What do you think? Arithmetic, because there's no exponent. But remember, with arithmetic, you don't get to just look at it and say, oh, that's A1, right? But this is arithmetic. What about 16? Geometric, right? And so in 16, what is A1? -5. What is R? 2, because those we can pick that out, right? All right, what is 17? Arithmetic. And in this case, it didn't say arithmetic, geometric, or neither. It just said arithmetic or geometric, right? What about 18? Geometric. What about 19? Geometric. How's 19 different than 18 besides the numbers? It is, yeah, it's infinite, right? And so is it convergent or divergent? Convergent, good. And then what is 20? Divergent. So it is geometric and it is divergent. All right, so are we good on the identification, right? Okay, grab the other sheet of paper. What did I do? Okay. Oh, I thought I did something wrong. Go ahead. because it depends on whether they're both infinite, right? But only one of them can I actually get a sum for, because you got to look at r. And if the absolute value of r is less than 1, it's convergent and you can give me a sum. If it's greater than 1, then it's divergent and you can't give me a sum. Okay? That's a good question. Anything else? I'm sorry that you're having that realization right now. All right, grab the other sheet of paper. We're going to do number 2. I also don't think we need to do, we're only going to do number 2. We don't need to do 1,000 of these either because you've already, we've been doing these anyway. If you could identify them, you're good. So number 2 says, Tucker took an 800 milligram dose of medicine for his headache. The table to the left shows the amount of medicine remaining in his bloodstream after each of the first 3 hours. After how many hours will the amount of medicine reach 500 milligrams? So after how many hours and 500 milligrams? So the first thing you want to do is look at this, decide if it is arithmetic or geometric. What? 50 milligrams. What about it? I said 500. Oh, I'm sorry. Thank you. I was like, yes, 50 milligrams. What do you take? Okay, 50. I don't know. I don't always know what comes out of my mouth, but 50 is. All right, so is it arithmetic or geometric? It'll be geometric. If you think about arithmetic, like if I subtracted here, then I clearly subtracted something that ends in a 0 and I didn't here. So my only option would be geometric there. So this is geometric. Okay. And then is this a sequence or a series? A sequence, because it's not asking me for a total of anything, right? I want to know what is this answer, the milligrams, at, after how many hours. So I'm looking for one specific term. So that means that, yes, it's geometric, but I'm looking at a geometric sequence, not a geometric series, right? So for that, I need A1. What's A1? 800, because that's how many milligrams it starts with, right? Then what is R? 17 over 20, right? 17 over 20. And then I don't know what n is. N is what I'm looking for. And I have an, right? An is what? 50. Okay, and I'm looking for a term, not a sum. That's another thing you have to determine. So we substitute all this in, and we get 50 is equal to 800 times, oops, I don't need times like that, r, which is 17 over 20 to the n minus 1 power. So what would I do here first? Divide by 800. And when I divide both sides by 800, I get 1 over 16 is equal to 17 over 20 to the n minus 1 power. What do I do next? Log, because you got to get that out of the exponent. So log of 1 over 16 equals n minus 1 in parentheses times the log of 17 over 20. Which would then mean that the log of 1/16 over the log of 17 over 20 is equal to n minus 1. So do that. Use your fraction and fraction thing. It'll turn out beautifully. Oh, yeah. I don't have a calculator in front of me. I think it's kind of in the middle. So once you divide, you should get 17.06, right? Then what do you need to do? Add 1. And so it'll be 18.06 hours. Okay. Any questions at this point? All right. Then we're done. And you're only going to do part of the stuff on the homework. I will tell you what that is after I give that to you. So on the assignment, you're going to do 2 through 18 even, and then 19 through 22. So basically, oops, the The stuff that's not the word problems, you're doing the evens, and then the 4 word problems at the end. Because you don't need to do 1,000 of these again either. But I want you to be able to actually, but on these, don't just identify them. Identify them and work them, which shouldn't take you that long. And the evens. But do exactly what the directions say, not how we did the notes. Okay. And then 19 through 22. Okay? Exactly. All right.